Hello, this is Mr. Win, and this video is about definition of logarithms or converting forms. So far in math, you've learned how to solve for x, whether it was in a fraction or it had an exponent, but what if x itself was the exponent? So how would you solve 3 to the x power equals 8? Well, 3 to the first power is 3, 3 squared is 9, but 8 is between 3 and 9, so we know it's a decimal, 1 point something. Now here's a hint, it is an infinite decimal that you could never ever guess. So we will solve this problem by the end of the video. But to solve problems where x is the exponent, we use a technique called logarithms, or logs for short. What logs do is get rid of exponents by bringing them down as a normal term, where we can then solve using our regular methods, such as getting x by itself if it's linear, or factoring our quadratic formula if it's quadratic. Because logs undo variable exponents, and the exponent must be a letter, it cannot be a number, logs are considered inverse functions of exponential functions and vice versa. So they're opposites or they undo each other, just like multiplication and division are opposites, adding, subtracting are opposites. Now make sure you know the difference. To get rid of a number exponent, for example, a square power, you take a root, use the square root. But to get rid of a variable exponent, x power, you cannot do an x root. You have to take a log. So all you need to do is really memorize this conversion formula, or my trick. Here's how it looks. B to the p power equals n, which is exponential form because there's an exponent p, can turn into capital P power equals log base b of n. And it's called logarithmic form because the word log's there. So it goes back and forth. And the letter B stands for base, the letter P stands for power or exponent, and the letter N stands for number or answer. Now keep in mind, other teachers may use different letters, but it's the same formula, and all logs must have a base. If it is invisible, if you don't see a little number down here, then it's by default a 10, just like a square root has an invisible 2. So let's try a problem. I put the form up here for us to look at, but you should technically memorize that. There are two ways to solve these, but convert each exponential form into logarithmic form. The first method kids like is they like just labeling each letter. So if I look at this, 4 squared equals 16, oh, that's a true fact. We know b is 4, that's the base. The power, the exponent p is 2, and the answer, number 16. Once you know those three letters, you just plug into the formula. So they want log form. Here's the equation for log form. You replace p with 2 equals log base b is 4, and the number n is 16. And we can easily check this in the calculator. So in the calculator, you turn it on, you press math, then you're gonna press up to log base, enter. I'm gonna do log base 4 of 16, and you'll see that the answer is 2. So that's true. All right, so this other method is more helpful when you're actually solving. Because we're in exponential, we'll go log form, we're gonna go to the exponent. To get rid of exponents, you take logs. My first step would be take a log of both sides. What you do one side, you do both sides. So I'm gonna do log base, and the base must match the base itself, 5. So log base 5 both sides. Now the nice thing is, when you have log base 5 of 5, those cancel out. So I'm going to go to the calculator fast. So for example, math up, log base, oops, wrong thing. Math up, enter. Log base 5 of 5, or 8 of 8 in this case, is 1. As long as the base and the number inside match, it cancels out. So log base 100 is also 1. So that's why log base 5 of 5 cancels out, and then whatever's left, the exponent just drops down in front. And the right side you leave alone. So my final answer, the left side is just 3 because everything else canceled. And the right side stays log base 5 of 125. So let me check that in the calculator. Math up. Log base 5 of 125 should be 3. And that is true, it's 3. All right, so two techniques. Either you label the letters and then plug in the formula, or you give exponents by log basing both sides. And then something should cancel out. The exponent should be by itself. So let's go to the reverse. Again, here's the formulas for you. Convert each of the following logarithmic form into exponential form. So identify the letters. Base down here is 7. The power, p is by itself, is 2. And the number inside the log is 49. Once you have this 3, you fill in the formula. B to the p equals n. So b, the base is 7. The power exponent is 2. 7 squared equals 49. And that's a true fact. It has to end on the true fact. Sometimes kids do it backwards. They'll say 2 to the 7th power is 49. That's wrong. So order does matter. Now there's also the trick for solving. To get rid of logs, you undo them by doing exponents. So you're gonna make both these sides exponents and use the correct base. So if the base is 4, our bottom is gonna be 4. So this is 4 to the exponent log base 4 of 64 and 4 to the exponent 3. Now the nice thing here is when you have a number, a base to the exponent of log of that same base, it cancels out. What's left will be the number inside. So just to show you here, I'm going to use a different one. So I use 8 again to the exponent, math up, log base 8, and any number here. So I put 1,000 or 111. Log 8 to the exponent log 8 is gone. It's just 111. So this is the inside. So it's just 64 on the left side equals 4 cubed, and you should know that's a true fact. All right, last two. Convert each to the other form. So here's the problem from the beginning of the presentation. 3 to what power equals 8? So you can use any method you want. You can label the letters and fill in the formula, or I'm going to do the solving one. Because I'm going to get rid of this exponent, I'm going to take a log of both sides. I'm going to log base 3. So that's the first step, log base 3 both sides. Then I notice log base 3 of 3 will cancel out, and the exponent x will drop down in front. The right side stays the same. So now we just get x equals log base 3 of 8. That is the answer. So in the calculator, if I press math up, log base 3 of 8, this is the exact answer, but it goes on forever. But you could say x is approximately that decimal. Now let's test it. Let's plug in. So 3 to the power 1.892789261 is 8.0000003, but it keeps going forever. So again, this is not the whole thing, it's an approximation. So that's how you find, solve for exponents that are variables. Right, other side, I'm going to go from log form to exponential form because I'm trying to get rid of the word log. I have to use exponents. So I'm going to figure out, I'll turn these both to exponents. I'm going to figure the correct base. Well, the base that matches base here, 10. So I'll put a base 10 on both sides. So 10 to this power equals 10 to that power. Well, 10 to the power of log base 10 cancels out. What's left is just x, and the right side is 10 squared. So the left side is x equals 10 squared. That's the answer, but you know numbers and exponents, you should fix them. 10 squared is really 100. So that's the final answer there. I can check. I'll plug in the original problem. So math up, log base 10 of 100 should be 2. 2 equals 2. That is true. And that's the whole video. Hope you enjoyed watching it. Make sure to ask your teacher any questions. Thanks for watching. Bye.